Moving on with our EOC review, and we're starting off with number 21. So here we have two triangles, and we're going to figure out what transformations could be applied to EBD to map it on to CBA. So first we're going to look to see if we could take it and do a 180-degree rotation. So if we rotate it 180 degrees, that's a 90, and then 180 degrees, and yep, that looks like a 180-degree rotation. Works. Now, it doesn't matter if it's one way or another. All right, if I went which way did I go? It looks like I went counterclockwise. If I go clockwise, it doesn't matter. It ends up in the same spot. Okay, how about let's do a reflection across the line x equals negative y. So that's a reflection across this line here. Okay, so if I just flipped it this way, doesn't look like that works very well. Okay, so that would not work. Okay, so how about if I did a reflection of the across the x-axis like this, okay, and then I reflected it across the y-axis like that. Well, that looks like that worked pretty good. Okay, so that a reflection x, then reflection y, and then conversely, if we reflected it across the y, well, that was an x then a y. That was a y then an x, but if we did the same thing, x and then y, we would end up in the same spot as well. Reflection y, then reflection x. All right, so those three would get you there. Okay? So next we have a number line. Let me find my ruler. Here it is. I have a number line. I'm going to call that number line AB, I guess. Excuse me. This is point A, and it's negative 3.6, and this is point B, and it's 10. And somewhere along the way is point P, and it's 5/8 the way. And somewhere along this way here, it passes through 0. So what's the difference between A and B? Well, it's going to be 3.6 this way and 10 that way. So it's going to be 13.6. That's the intuitive way to look at it. The mathematical way to look at it is that the difference between A and B, right? This is your final, this is your initial. Right, the delta is going to be your final minus your initial, which is going to be 10 minus negative 3.6, right, which is going to be 10 minus negative 3.6, which is 10 plus 3.6, which is 13.6. This is the algebra mathy way, and this is the intuitive way. Either way, this whole thing here is 13.6, of which we're trying to figure out what 5/8 the way of that is. So we take a calculator, which I have way over here, way over here, and 5/8 the way of the whole thing of 5/8 of 13.6. Whenever you say of in a calculation, it's times, right? And so that is 8.5. So like this is 8.5. 8.5, and this is point P. All right, so that's how that whole thing works. All right. Next, we have a line, part of a triangle, and this is a PQR, and we have 2 points. We have point Q, which is -2. Let me zoom in a little bit here to see better. All right, so we have point 2. Make some room to slide this up. All right, so we have point 2 and -4. So we have point 2 and negative, wait, is it? No, it's -2, -4. -2, -4, and that's point Q. And then we have point R, which is 0 and 1. So this is point R, and we have a line between those two. There's a line between these two. All right, and then the question is, we have point P is the other right triangle. What are some other points that P could be? Okay, so let's, how about this one? This is 6, 0. So 6, 0 is right here. And then we have, let's see, blue one. This is 5, comma, negative 1. 5, comma, negative 1 is this one. That's the blue one. All right, then we have 2, comma, negative 4. I have 2, comma, negative 4. There's no way. That looks like an isosceles triangle. So I'm just going to say no right away with that one. That's not, no way is that a right triangle. Oh, you can't even see what I'm doing. Okay, and then the green one is negative 2. What is the other color? How about burgundy? Negative 2 and 1. So yeah, that's a right triangle for sure, because it just goes right down and makes a right angle right here. So that for sure is a right triangle. But we have to evaluate these other two. So let me go ahead and make these a little bit better and more visible. So I have this one angle here, right here, this line, this orange one, and then this blue one. This blue one to look at. I'm pretty certain that I'm not even going to bother wasting time on this pink one. It's not a right angle at all. But I have this blue one, and I have this orange one here to look at. So I could calculate it and then figure out like the hypotenuse and then do some Pythagorean's theorem stuff, or I could compare slopes. All right, so first I'm going to figure out what the slope between, the slope of PQ is. I'm sorry, the slope of QR is. All right, so the slope I'm comparing it to, slope of QR is going to be, I'm going to look at just it's positive. I have this coordinate plane to deal with, so I can just use it. I can use qualitative looking at. I don't have to do any math really, right? So it's positive because it's going from left to right. It's going up, so it's positive. And my change in y, my absolute value, my change in y is looks like goes from 1 to 5 or 4. So my change in y is 5, and my change in this is 5 halves. Okay, so my reciprocal value that I need to be looking for, or my parallel value, my perpendicular value, my 90 degrees, is gonna have to be opposite and reciprocal. So I'm looking for something that is negative 2/5, has a slope of negative 2/5. So let's look at the orange one. The orange one has a negative slope. Okay, it's going downward, and my change in y looks like it goes from 1 over a period of 6. Yeah, so that's not one. Nope, that's not a good one. And then how about my next one? This one looks like it goes from 2. It's negative, and then it goes down 2 over a period of 5. Hey, yeah, that's it. That one works. All right, so this point, my blue line, that was derived from this point here. That one's a good one. Yeah, so it's these two points are the ones that work for that one. All right, moving on to this one. Okay, so I'm given this quadrilateral, right, and it's ABCD with these vertices, negative 3, 4, 1, 5, and 5 and 3. And I'll go ahead and plot these while you watch me. Oh, actually, I'll just pause it while you plot these. All right, so I'm all done plotted my quadrilateral, and it looks like I have 2 parallel lines here, and then this thing's going up and down, and this thing's kind of going side to side. So it looks like I have a trapezoid. I'm gonna guess a trapezoid, but I gotta prove it. So I think I got BC, I think BC is parallel to AD, and I gotta prove it. If so, AD's slope, I might have put M behind it. The slope of AD, let's do the math. The slope of AD and the slope of BC would be the same. And so they're both negative. Okay, so remember the slope is change in y over the change in x, right? I'm going to do the qualitative look at it, so I'm just looking at the absolute values, right? Because they're both going down, so they're both negative, right? My change in y for BC, BC is going to goes from 5 to 2, right? So that is a 3 change in y over a, let's see, it goes from 1 to 4, so that's a 4 change, so that's negative 3/4. Oh, wait a second, I probably counted that wrong. Let me double check that. Okay, so it goes from 5 to, let's see, it goes 1, 2, 3. Okay, so it goes down 3, and it goes over 1, 2, 3, 4. Okay, that's right. Okay, and how about AD? Check those points again. Thought there was something fishy going on. I plotted C wrong, right? C was plotted at 5.2 and not 5.3. So I replotted it, and let's do the math again. Sorry about that. Right, so the change in y is actually 2. It goes 1, 2. So the change in y is 2, and then my change in x is 4. It's negative 2/4. Did I write a 2? I don't know. It's negative 2/4. Okay. Again, shows you the importance of double checking your plotting points. Right. If I had done this using the algebraic method, I probably would not have made that error. Okay. So this is negative 1/2. Okay, and then my change in my slope for AD is going to be negative, and then from AD it goes from 3, so it's going to go 3 to 5, so it's going to be x is my change, that's my change in x, and then my change in y is from 3 to 8. I messed that one up too. So it's going to be 1, 2, 3, 4. No, it's 4 to 8. So that's 4. Right. So that's negative 1/2. That's negative 1/2. Right. So these are the same slopes. Because these are the same slopes, I can say that these are parallel. Okay. Now the other question is this even more similar? Is this an isosceles trapezoid? Well, that's pretty obvious that it's not. Right. What is the length of this? What is the length of this one versus this one, right? Well, I kind of drew that kind of funny, right? Because in order to count this length here, it's just C to D, which is 3, which would be 3 to 8, would be 11, right? And then from here to here, it would be, that's 5 to negative 4, so that would be 9, and this would be 1, 2, 3, 4, which would be 4. So this would be the square root of 9 squared plus 4 squared. 9 squared plus 4 squared equals, take the square root of that, 9.8-ish. 9.8-ish. Which is not equal to 11, right? So these are not congruent. So it's just a trapezoid. Just a trapezoid, not an isosceles trapezoid. Okay. All right, so moving on to the next one. This is number 25. Number 25. Maybe I can move this up a little bit, give you guys a better view. Okay. Number 25, we have 3 vertices of a quadrilateral. And what's the other vertice? All right, so P Our number Q is -1 and -4, or -1 and 4. -1 and 4 is way up here, and that's Q. Get rid of this guy. Okay, we have 1 and -5, which is this guy, and that's R. And then we have S, which is -3 and -2, which is this guy. And combined together, we have now all of these 3 points, and we need to find the 4th point, which is going to be up here somewhere. So we need to figure out the slope of SQS and the slope of SR, and then extrapolate 2 lines based upon those 2 slopes and see where they intercept. Okay, so the slope of QS is the change in Y over the change in X. I put it inside because we're looking at qualitative looks, and QS is positive slope, and the change in Y goes from 4 to 2, so that's going to be a change of 8 over a change of, oh, not 8, that's 2. What am I thinking? That's 2, right? And that's going to be a change in X of, no, not 2, 3, excuse me. That's 6, and then this is going to be a change in 2. So my overall slope is going to be 3, or 3 over 1, right? So this parallel line is going to go 3 up, 1, 2, 3, and 1 over. Right, 3 up, 1, 2, 3, 1, 2, 3, and 1 over. So if I did that right, I'll draw a line, and all 3 of those points should line up. And I'll just kind of draw a line like that, and that'll be my line that's parallel to that line. Okay. Now my SR line, my slope of SR is going to be my change in Y with my change in X, right, either positive or negative, and my SR goes down, positive or negative. My SO goes down, so it's a negative slope. My change in Y goes from here to here. Looks like it's going to be a -3. It's going to be 3. It's 3. My change in Y is, oh, that was my change in Y. It goes from 3 to -3. That's 3. My change in X is 4 is -3/4. Right, so go from here, and I go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Hey, look at that. Coincidence. Right, so here is my point P. I'll just erase all this extra stuff that I don't need, and my point P is located at 3, 1. That's my point P. And if I wanted to, I could look at this triangle to verify that this length is 2. This length is 1, 2, 3, 4, 5, 6. Yep. And then this length here is 2. This length is 1, 2, 3, 4, 5, 6. That's okay. So these lines are the same. And then this is 1, 2, 3, 4, 5. 1, 2, 3. This is no, it's 4. And then this is going to be 3. And so this will be a 1, 2, 3 by a 1, 2, 3, 4. Yep, so all these lengths are the same. So that should show you that these are parallel and congruent, and parallel, and parallel, and parallel. Okay, next one. Okay, so now we have 2 points. 2 points, we have 0, 0, 0, 0, and nope, that's the wrong point. We have 0, 2 is A, and 2, 0 is C, and these are the opposite sides of a quadrilateral, and it's a rhombus, not a square. Remember, a rhombus has all sides are congruent. It's an ugly congruent sign. Are congruent, but the interior angles are not. only, you have two sets, right? Opposite sides are congruent, okay? So let's go ahead and plot what they give us. What is this? This green set. Green set over here is 0, 0, and 2, 2, and that looks like a square. So not that one. And we have a pink set of -2 and 0, and then 4 and 2. And if I plot that, that looks to me like a parallelogram, just a plain old parallelogram, which is not a rhombus. Then I'm going to go to, I don't know, red. Let's go to a red one. How about this one? And this is a 2. No, this is a 2 and a 4, and then a 4 and a 2. And if I do this, this looks like it's just a square on its side, right? I don't know, if I really wanted to be sure, I would do some Pythagorean theorems or some slopes, but I'm pretty sure I'll save it. I won't eliminate it yet, but I'm fairly confident that that's not it. And then let's look at -2, and 4 and 4. 4 and 4. These are kind of spaced out. I'm going to use a ruler. All right, now it's getting kind of crowded. So I got these guys here, and then this guy here and here. Make a mistake here. These guys here. Okay. And then these two here. And these two here. Okay, this is looking right. All right, yeah. So it looks like these are all congruent, and these two are the same, and these two are the same. So it looks like this is going to be my rhombus. So do I have an orange? Oh, yeah, I do. Okay. So I'm going to go ahead and highlight that so it really pops out. So this here is my rhombus. This is my rhombus. Yeah, that is what I'm talking about right there. These guys, this guy, this guy, this guy, and this guy, and these guys. I'll just color those in. Yeah, so that's my rhombus. That's what I got going on, and that is this one. So anyway, moving on to the next one. Okay, so I have a line tangent. Move this up a little. So I have a line tangent equation, and then I have a center point at that point. So, and I got to figure out what is the point that they intersect. Where does the circle intercept that tangent? Okay, so first thing we got to do is draw a tangent line. Let's go ahead and just draw it, and I'll show you the algebraic way to figure this out too later. We got to put this in line intercept form. So it's going to be 2y equals -x plus 10. I just move the x over here. Divide both sides by 2 equals -1/2 x plus 5. All right, y-intercept is 5. Okay, so every 1 down is 2 over. That's a -1 and an x. All right, so that's enough to plot my points. I will draw these points as close as I can get them, and that is going to be my line y equals -1/2 x plus 5. Okay, then I have a point of 2. My point is 2, comma 1, -1. Which is right here, 2, -1. That is my point, right? And I got to find the line tangent to that. All right, so I know that my tangent point, right? A tangent point intercepts a radius at 90 degrees or perpendicular. So the radius, so the slope of a radius here, right, would equal the opposite inverse. So it's going to be 2 over 1, or just 2, okay? So I'm going to come over here and just do a 2 over 1, 2 over 1, right? And I'm going to go ahead and draw this and see where it intercepts at 2 over 1, and it looks like, let me just continue 2 up 2 over 1, yeah, look at it right there. So it looks, just by doing that, I can figure out already that this point intercepts at 4, 3. Right, but there was a little bit of space, like some space, maybe that was just wishful thinking, right? There was some wiggle room there. So let me calculate that. Okay. First thing I want to do is find a real good line, a real good equation for this line, right? And I know these 2 points that it's got to pass through, right? So I can find my equation is going to be y equals 2x plus something, which is my b, right? Well, if I have this, that's going to pass through this equation. Let me change this to a different color. Let me change this to a different color. This is my point right here. This is my point. Okay, so this is 2 comma negative 1, 2 comma negative 1. All right, so y equals 2x plus b. Let me drop these values in for here. So y is negative 1 equals plus b 2, and then x is 2. All right, do the math. That's going to be 4. Bring it over here. It's going to be negative 5 equals b. So my equation for this line is y equals 2x minus 5, because 5 is b, so I just slap it in there. Therefore, y equals 2x minus b. Okay, so if I were to continue this down to like negative 5, you would see that here, this would kind of intercept at negative 5. Makes sense, okay? So now my question is, where does it intercept? Where do these 2 lines equal each other? Where do they intercept? Where they equal each other? Well, I have to make this equation match this equation at the y. Okay, so let's set 2x. Why did I put b there? This should be 5. 2x minus 5 equals negative 1/2 x plus 5. All right, so now let's just go ahead and turn this all to a different color. And it's going to be 4x minus 10 equals negative x plus 10. Okay, I just cleared the fractions. Now I'm going to bring this over to here. This is going to be 5x equals 20, right? And then x equals 4. Okay, so when these equal each other, my x value, sure as heck, equals 4. And it does. So then I take this value, 4, and I drop it into, we'll say, back to here. When x equals 4, this is my y value. So if x equals 4, x equals 4, 2 times 4 minus 5, that's 8, minus 5 is 3, y equals 3. So my points would be 4, 3, and there it is. Okay? So that's how you would figure it out algebraically. All right, moving on. Given a triangle whose vertices are 3, 4, 2, 1.7, and reflected across, then transformed, what would be the new coordinates? Okay, so let's call this one A, B, and C. Okay, and that's what we do a, I don't know, I have time for this one. All right, so we have A, B, C, -3, 2, 1.7, comma, 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 1 point, nope, that's 4, 4, 1.7, and -3. Okay, and something's gonna reflection. Triangle is reflected across the Y. All right, so that's the first one: A prime, B prime, C prime, comma, 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 chameleon. I'm just joking. All right, and then it's going to reflect across the Y-axis. So when a reflection just across one axis, the X and the Y stay the same. When it reflects across the Y-axis, the X flops. Okay? So we're going to keep all these things the same. All the values stay the same. So 4 stays the same. 1, is that -1.7? No, it's 1.7 stays the same, and -3 stays the same. But all the values for these things flop. So that's going to be 3, -2, and -1.7. -1.7. Okay. Then it's transformed. Color. Then it's transformed. Looks like it's a transformation or a translation, right, to A double prime, B double prime, C double prime, and it's going to be with -3, comma, and +4. So this is going to be 6. Oh no, that's not right. This will be 0, 0, -5, and -4.7. Okay, this will be 8. This will be 5.7, and this will be 1. Okay, well, that's all I have time for right now. I will get with the rest of these and keep going as the days go by. Hope you guys learned something from this, and I hope this helped. These, by the way, are the new coordinates after those 2 transformations. Have a great day.